Welcome to Ask and Learn.
All right, guys, we're doing problem number 90 of chapter 18 in Chemistry of Central Science. So the precipitation of aluminum hydroxide with KSP 1.3 times 10 negative 33rd is sometimes used to purify water. Estimate the pH at which precipitation of LiOH will begin if 5 pounds of aluminum sulfate is added to 100 grams of water. So let's set up our KSP reaction. KSP is going to be Al3 plus OH3 OH minus to the third. So if our concentration So basically what this means is that if this product of Al3 plus and OH minus to the third exceeds our KSP value at that point, we will start seeing precipitation. So first we're going to find the concentration of our aluminum. So 1 pound is equal to 22,000 grams. So 5 pounds. Sorry, 1 pound is not 22,000 grams. My mistake. 1 pound is 453 grams. 400, or rounded off, it's 453.6 grams. So we have 5 pounds of aluminum. So 453.6 times 5, that's going to be 2,268 grams. So we're going to write this 1,268 grams. Over 342.15 grams per mole. That's going to be equal to 6.633 moles of aluminum sulfate. And since there are 2 aluminum atoms for every sulfate atom, so for every sulfate molecule, we're going to multiply this by 2. That's going to be 13.26 moles of Al plus. Now, we're going to convert this to concentration. In fact, I might as well just get a new board. So 1 so 1 point, so 13.26 moles. And now we have 2,000 gallons of water. 1 gallon is equal to 3.78 milliliters. So 3.78 times 2,000, that's going to be 7,560 liters, which is going to equal concentration of (1.75 times 10 to the negative third molar. And so we can actually manipulate this equation. So we can rewrite this as the cubed root of KSP over Al3 plus is equal to hydroxide concentration. So the cubed root of 1.3 times 10, times 10 to the negative 33 over the concentration. So 1.75 times 10 to the negative 33 times 10 to the negative 3 is equal to hydroxide concentration. So hydroxide concentration is going to be here's so 9.06 times 10 to the negative 11th molar. So now that's going to be the concentration above which our aluminum hydroxide is going to precipitate. Right? So you can see that's a very low concentration of our of hydroxide. So this is going to precipitate pretty readily when we put in solution. So now the pH we're going to use is going to be pH minus 14 minus POH. And POH, that's going to be E minus the log of OH concentration. Yes. So now pH is going to equal 14 minus plus the log of OH of 9.06 times 10 to the negative 11th. So pH is equal to 3.96. So that's the pH at which aluminum hydroxide is going to precipitate. You can see that's actually a pretty acidic pH, so this would precipitate pretty readily. Now, B. Approximately how many pounds of calcium hydroxide of calcium oxide must be added to the water to achieve this pH. So if we have calcium oxide here, it's going to react with water to form calcium hydroxide, which will further yield Ca2 plus 2OH minus. So we know the concentration of calcium that we're going to be using. We know the concentration of hydroxide that we have. That's going to be 9.06 times 10 to the negative 11th. So we're going to multiply that. Eleven times 1 mole CaO over 2 moles of OH minus yields this concentration. 4.53 times 10 to the negative 11th molar. Now we have to convert that to pounds. 4.53 times 10 to the 11th molar. And we're in 2,000 gallons. Sorry, 1,000 liters. Sorry. Yeah, we're in 2,000 gallons, which we're going to convert to liters. So that is 7,560 liters. And then that gives us moles. So then we're going to multiply that by the molecular weight, which is going to be 56.1 grams per mole. And then we're going to convert it to pounds. So we have 1 pound per 453.6 grams. So that means the mass of calcium oxide, that's going to be that's going to be 4.24 or times 10 to the negative 8 grams of our calcium oxide.